Hello class, this is a video tutorial on the area formula of other quadrilaterals. In this video we're going to look at the formulas for the following shapes: for parallelograms, for rhombus, kite or diamonds, and trapeziums. If you're going to look for the area formula for squares, rectangles, and triangles, that's in my other videos. But in this video we're going to look at these shapes, and we're going to be doing a few examples in the next page. So here we go. Let's begin first with the parallelogram. With the parallelogram, the two dimensions that we need to measure are actually its length. So let's give this a label. That is L for length, and we actually need its height. A little dotted line here. And notice how its height is perpendicular to its length. So that's H for height. Now I'm going to draw in red here because I really want to emphasize that this is not one that we use. For the area, we do not use this diagonal. Put D for diagonal. We do not use the diagonal for the area of a parallelogram, or pretty much any shape for that matter. The two dimensions, or the two lengths that we need, are perpendicular to each other. So the area for this is area equals L times H, or you can just write it as LH. Okay, moving right along. For the rhombus, kite, or diamond, they actually have the same area formula, and unlike parallelograms, rhombuses, and squares, we don't use the sides themselves. We actually use the diagonals of rhombuses or diamonds or kites. So I'm going to draw my diagonal here. It's one diagonal. There is the other diagonal. There we are. And we know from previous units that they are perpendicular to each other. And the area for these, actually, now before I go on, I'm going to draw the diagonals as well for this, for our diamond or kite, whichever you want to call it. It's one diagonal, the other diagonal. Okay, and we're going to label these diagonals, not L, because L refers to the length of one of the sides. Instead, I'm going to label it, I'm going to draw little arrows here so you can see. So from that side to that side, I'm going to label that X, and we'll label the other way. Well, it's a bit tight here, a bit cramped. This other way, so the other diagonal, let's label that Y, and same goes for our diamond here. We'll label that X, and this way Y. It doesn't really matter what we label these. We can have it A and B, X or Y. But just for this example, we're going to label it X and Y. And the area for a rhombus, kite, or diamond, so area is given as 1/2 times X times Y. Or we can simplify it as half X, Y. Okay, so that's the formula we're going to be using. And finally, here we have a trapezium. For a trapezium, we actually need 3 different numbers. We're going to label the 2 parallel sides. Let's label this side A and side B. And we'll get once again, the perpendicular height. We need that height that is at a 90-degree angle. We'll label that H for height. And once again, I'm going to really emphasize that we do not use that diagonal, D for diagonal, D for diagonal. We do not use that side. Not for the area. The area of this shape, we do not use the diagonal. This one's a little bit more complicated. So the area of a trapezium is, we add the two parallel sides, so A plus B, and then we halve that, and then we multiply it by the height. Or we can just do it as A plus B over 2 times H. So now we're going to use these three formulas. I'm going to highlight them, or at least box them in, because they are important. I'm going to use that one, and that one. We're going to be using these three in our examples following now. Here we go. Here we have 4 examples. We have a rhombus, parallelogram, kite, and a trapezium. So let's get straight into it. Now here we have a rhombus, and from what we just saw, the area of a rhombus is half x, y. Just so that we can label our values, let's label this one x, and this one y. And let's substitute these numbers 9 and 14 into our formula. Here we go. 1/2 times 14 times 9. And since this is all multiplication, we can do half times 14. So 1/2 of 14 is 7 times 9. 7 times 9 gives us 63, and since our shape is in centimeters, so we'll put it in centimeter squared. Moving right along, a parallelogram. The area of a parallelogram is length times height, LH. Let's label our sides. This side here is L, and this here is our perpendicular height, so H. L is 12, so 12 times 8 gives us 96. It's in meters, so we put it in meter squared. Moving right along again. Here we have a diamond or a kite. The area for a diamond or a kite is the same as a rhombus, so half x, y. And let's label our sides. Let's label this x, and this side y. And then substituting, so putting the numbers into our formula, we get half times x, which is 15, times 12. Just a little few tricks that we can do here. 1/2 times 12 gives me 6 times 15. More tricks that we can do here. 6 times 15, 6 times 10 is 60. 6 times 5 is 30. So 6 times 15 is 90. Since it's in kilometers, we get 90 kilometers squared. For our last example here, the trapezium. The area for a trapezium is, we add A plus B, then we halve it. So we do this first, and then we multiply it by our height of H. So let's label our points. 10 will be A, 16 will be B, and our height will be 9. Substituting our values, A and B, so we get 10 plus 16 divided by 2 times 9. 10 plus 16 is 26 divided by 2 times 9. 26 divided by 2 is 13 times 9, once again, doing a little tricks. 9 times 10, this 1 here, is 90, plus 9 times 3, 27, which gives us 117. Since we don't have any values here, let's just put it in 117 units squared. So that gives us 4 examples for the area formula of other quadrilaterals, and I hope that gave you an insight into calculating the area of these shapes. Best of luck.